In this video, we will talk about operations on set. So what all operations or mathematical functions you can perform on set. Before we start what different operations, there's one thing which is very important to understand, which is Venn diagram. It was invented, or it was first shown by John Venn, and it is the diagrammatic diagram to represent sets. So diagram to represent sets. So let's take an example. Let's say there is a set U which has the values 1, 2, 3, 4, 5, 6, 7. And then there is a set A which has value 1, 3, and 5. The way to represent these two sets as a diagram is saying we have one big set U, right, which has values 1, 2, 3, 4, 5, 6, and 7. And within that there is a set A which is 1, 3, and 5. So what we say U as the universal set and A is part of that universal set. There could be another set within this set which takes value 2 and 5. So suppose there is another set B which takes value 2 and 5. There could be another set C which takes value 6 and 7. Right? So basically you can say that there is a universal set which has the 7 elements, and within that 7 elements there are multiple sets which is A, B, and C. Right? So this is how you represent sets using Venn diagram. So that is what you said, there is a universal set U which is represented by set of objects, and there are sets like A which is another set of objects, and there is a set B which is another set of objects which belongs to U. This is what we call, this is how we represent Venn diagram. Right? We will use the Venn diagram ways to define a lot of set operations. Right? So let's see. Subsets. Right? So what does that mean? Let's say there is a set A which takes all values so X says that X are students of school. And then there is a set B, Y, so that Y are student of same school but of class 12th, right? So we say there is a universal set, or there is a big set A. There is a set A which is basically all students in class 12, and then there is a set B which basically belongs to A, which is contained in A because they are all school, they are the same students of same school, but only class 12. So it is equal or lower than set A. So in this context, we say B is a subset of A. There may be a school which only has class 12, right? So B is subset or equal to A. Right? So a few remarks before we move forward, which is a set is always a subset of itself, right? Null set is subset of all sets. So if A is subset of B and B is subset of A, that strictly means A is equals to B. And fourth, if A is subset of B and A is not equals to B, this implies A is a pure subset of B. So in this case, B is said to be a superset of A. We can also write as B is a superset of A. Right? So we have seen what is Venn diagram. We have seen how you represent subsets in the Venn diagram, right? So if you have a set A and then there is a set B which belongs to A, then this is how you represent it on the Venn diagram. There may be all of them maybe belong to a complete universal set U. Both A and B can belong to a set. So this is how you represent a subset in Venn diagram. Right? Now let's see another concept, which is power set. Right? There is a set A, just two elements, 1 and 2. Right? So what are the subsets of A? If you want to write all the subsets of A, what are they? So phi is a subset of A, right? 1 is a subset of A, 2 is a subset of A, 1 and 2 is a subset of A, right? Now we make another set B, which contains all of these, right? So all possible subset of A is in B, right? So B is the collection of sets. So the object here is sets, which is basically a subset of A. So B is then called a power set of A. Where B is collection of all subsets of A. Right? So suppose if let's take an example. If C is equals to A, B, and C, then and if D is power set of C, then D is equals to a bigger set with, so phi A, B, C, A, B, B, C, C, A, and A, B, C. Right? So D is the power set of C, that is, it contains all possible subset of C. So we will conclude this video here, but we will continue set operations on set in the coming videos. So another few other videos will have more set operations.